Hi there, Michael here again, and today we're going to talk about software philosophies or software principles if you prefer. This is about how to think and reason when you are doing code. And I'm going to show you some guidelines, perhaps golden rules, at least something to relate to that when you are in the middle of your coding process and then you have to take a decision on how you're going to write the code at this particular time. And perhaps you know that there are several ways you could go. You could put a lot of effort into it or small effort at the time being. And then when you are there trying to make the decision, then these software philosophies that I'm going to show you can actually sort of help you make the proper decision for that particular sort of time in space that you have your code. So let's see a bit about what I have here. It's a short agenda. It's a long slide, short agenda. We're going to review some software philosophies and talk a bit about how you can then use them. And we can start here. I guess you have heard about the Zen of Python. At least you have if you're most likely to if you're a Python programmer. So this is basically, you call it the Easter egg. So if you open up the Python interpreter and you import this, then it comes out here. So it's a set of 19 rules. It's called PEP 20, but it's only 19 rules. So these are, if you look at them, sort of beautiful is better than ugly, explicit is better than implicit, simple is better than complex. You see, there are play of words, you can almost say, but when you actually try to relate to these and you are a Python programmer, these pretty much makes sense. So these are then some rules, perhaps golden, for the Python community of programmers. So if you want to be a Pythonic programmer, then you most likely should try to adhere to these rules, should be aware of them. And when you are sort of writing your code that other people most likely will be able to see, you should also try to relate to these sort of rules set. So these, even if you think they are sort of high level talk, words about code, they are actually steering or governing sort of a whole community of Pythonic programmers. So it could be good to know what kind of rules is sort of behind the code that these good Pythonic programmers are writing. And I just want to talk a bit about the philosophy term. If you feel that philosophy is just sort of high level talk, only words, nothing is happening. And perhaps it is like that, but also in my mind, philosophy and I'm philosophizing, or I'm talking about things and I'm trying to relate, put things into a specific context. And this I do basically in search of knowledge. I'm trying to search wisdom. And so that is a good thing. That is actually a process of learning. So this philosophy thing that we will be doing now, a lot of software principles or software philosophies on how to do things, they are actually, you should see them as a process of learning how to become a good programmer. That would be the way that I would sort of relate to these software philosophies. And let's review some of them. I have a list of them and it's pretty long. I could even have made it longer, but when you just sort of add these philosophies on top of each other, it's at the end it's just too much. So I picked out a few of them. I think it's a good setup. So we're gonna see here Drykiss, Pogyagni. Yeah, we're gonna see what it's all about. Let's start. So the first one is rather simple, and perhaps you have heard it before. I think it's one of the most earliest or common principles that you hear from your peers when you're starting to learn to write code. So it's about being dry, and dry means don't repeat yourself. And that is what someone is telling you when you have copy pasted your code. So you have same code parts all over the place. And there is really a need to reorganize your code and perhaps start to use modules, functions, some way to reuse the code in a better sense. So, well, at those times, they're going to tell you, Michael, you're not dry here. You need to fix that. It's too ugly. So it's about duplicating code and or avoiding duplicating code. Another principle is KISS, and that is also one of the one of the principles that you hear first of them all, perhaps. Yeah, KISS and dry. So KISS here is keep it stupid simple, and that's basically saying don't mess things up, don't complicate things. Why do you even bother to put all that effort into what you're doing? If there is an easy path, take it. If there is an easy path, just take it. And that is what KISS is telling us. So when someone is telling you, okay, shouldn't we go with KISS this time, Michael? Just this time. I will think about it. Okay, yeah, I see there is an easy path to solve this problem. Let's do it the KISS way this particular time. Okay? So let's move on with the more software philosophies. POGE. POGE is a principle of good enough. So this tries to tell us that sometimes we are sort of spending more time in the code than it's worth the value we're putting into it. Shouldn't we sort of say, okay, I have reached an acceptable, reasonable level of features or code quality. This is good enough. So principle of good enough could sort of help you to drag yourself out of these small fine-tuning of codes that maybe is not actually needed at the current level that your program is going to work with. So POGE, ain't it good enough now? Yagni is good to have when you're reviewing a requirement specification or you're feeling that you're just adding more and more features to the requirement specification. You're adding these nice to have feature. Wouldn't it be nice if my code worked like this? But do we really need it? Really? Can't we just, will we suffice even without this? So Yagni is stating, you ain't gonna need it. And when you are in these situations, do bring the Yagni principle with you. So when you're adding too much feature, you could just say, Yagni, are we really gonna need that one? And Yagni is sort of related to the Pareto principle. It's 80-20 principle, and it's basically saying that the absolute majority of your users, let's say 80%, they will only use a limited amount of your features in your application, let's say 20%. And this type of, so 80% of the users will only use 20% of the features. So that means that the main usage of your application will only be using a small core of the features. What are the other features doing there? So this and Yagni is really good to bring with you when you're sort of removing stuff or sort of prioritizing thing. And these are sort of good to know. It's a generic principle and can be sort of used on many different cases, but we use it on programming here. Copy-paste programming, this could actually be good to know that it's a valid way of going. So this would be, maybe you have a program, it's working, and now your customer says, okay, I want the same program, but I want it in this context instead. And you know that you can take that copy-paste program and make it work in 10 minutes. But it's going to be copy and paste program, so it's ugly code. You just go in and hard code some variables, and then it's going to work, and then you're going to sit there with two almost equal programs and maintain that. But that is still a valid way, copy and paste programming, because sometimes you just need to do things quickly. And if there is a quick way, well, sometimes you can take it, and then you can sort of build a nice structure tomorrow instead. So this is, in my view, a fair principle. Another principle that will make you save some time and work, that says don't fix it. If it ain't broke, well, don't fix it. If it's just working, and you might be aware of some things in it that should be fixable, but everybody else says, hey, it's working, so you shouldn't go in there and try to fix something. And if you do, maybe you will break something else. So if it ain't broke, don't fix it. That's a general good rule of advice to save you some time and disturbances. Proof of concept, or POC, that is a general way of thought on how building something quick and dirty just to show off the concept. And even sort of when you do this type of code, you can even build it, make it work, and then just throw it away, throw on away. And this is also something you can do when you do a completely new application, but you could also use it in your project and say, okay, for that part of the program, let's just do a POC, proof of concept, and then leave it with that, and then we focus on other things. So do not overdo it. Even here, we are sort of trying to save ourselves some time. Fake it until you make it. I was a bit curious if I'm gonna have it here, if I can relate it to software engineering. I have some friends that usually tell me to sometimes use this as a good advice. It's generally saying that the rule is, or the principle is, that do something, make it look good, and the users will sort of imagine that it's actually working. And sometimes this could be a good way to sort of give an early delivery, or I am really faking it. I know that the code does not give all the answers currently, but I'm still going ahead and showing a very good sort of user interface, and perhaps my users won't even try that part of the code, so I'm faking it. And maybe I'll make it, maybe I won't, but I'm gonna keep on faking it until I make it. So it's one general principle. We could use it for software engineering, programming, and in other ways of life, of course, too. So it will be still here in the slides, yeah. Overdo it is, I can relate to that. I get into these occasions when I'm in my code and I really want it to look good, be very maintainable, flexible, can even sort of use it in different ways, even if that is not the current subject of today, but maybe tomorrow, who knows. But maybe I'm then overdoing it, or I'm over-engineering them. I'm overthinking the problem. And this is about building a more robust product than is actually needed for the current environment that it's going to live in. So save time again, don't overdo it. You heard there's a lot of principles here that are trying us to help us save our own time. So that's very nice of them. Satisfy and suffice. So that's a strategy for decision making, and that could be good to use it when there is no actual optimal solutions. All the solutions to a problem are sort of, okay, that was fair but not good, that was fair not good. So we're having a lot of solutions, but none is really optimal. So we only go through the solutions, then we take the sort of second best, or the one that is sort of, it has an acceptable level for some or many of the features or whatever we're going to do. So satisfy and suffice. It's a when an optimal solution is not the alternative, yeah, take some other solution that is reasonable, okay, satisfying. Worse is better is could be say we could relate it to perhaps the Pareto principle or the Yagni principle. You ain't gonna need it. That's saying that your software, your program, your application is not necessarily better just because you're going to fill it with a lot of features. It could be the opposite, that by removing a great number of features, you are actually doing your users a favor and yourself, and your program is getting better. So yeah, that might really be true. That is what this principle is telling us. So when you are there, you're having an application with a lot of features in it, okay, give it a thought. It's worse might be better this time. Less is more. Reduce the amount of features and get a better product. Tim Toady is a Perl programming motto. So it's a way of expressing things when you are a Perl programmer. So it's a programming language. And that says that there's more than one way to do it. We can do things in different ways, and that is valid. It is fine in this programming context to actually, I did it this way. I coded it this way. And I coded it that way. And they all did the same, looked completely different, but that is okay. So it's a Tim Toady. Okay. It's just a way of saying, expressing that, yeah, it's okay to do things differently. On the other hand, the Python programming motto from the PEP 20, there should be one, and preferably only one way, and it should be the obvious way of doing it. So this is when you are a Python programmer, then that there should actually be only one recommended way of sort of creating a program construct to do a certain thing. And in this context, then it's sort of a guiding, yay, when you are doing it as a Python programmer, you should do it like this. So it's sort of building up the structure on how you actually should do a bit more harder rules. So you see here that this rule in the PEP 20 is sort of basically same opposite of what Tim Toady in the Perl programming motto was saying. But this is the general way of these principles. They sort of don't they clash into each other. They can be contradicting. They say opposite things. And but that's fair, that's good. So here in this way, then I can do on this PEP 20 should be one way of doing it, or I could use Tim Toady saying no, it's fair to do it on other ways, and then I just choose the proper principle and I stick to it and I go ahead with it for the time being until I take another principle and then I go ahead with that. So these are principles that are sort of guiding lights, helping us to reason. They are not sort of the absolute correct way of doing things. They are just ways of thinking and taking decisions, and they might also have some consequence when you go ahead on that line, but you know more or less what the consequence is. Okay, good. Premature optimization. As we say down there is the root of all evil. That's pretty hard, but this is a principle that's saying that uh, do not try to optimize your program at first. It even says, like, in the 97% of times you're trying to optimize your program with these small efficiencies, then you should just forget it. Don't do it. Ignore it. You don't earn anything of it, and it can take a lot of time and effort for your coding and from your discussion with your sort of teammates and peers. So just forget it, because you're doing premature optimization. You're optimizing stuff before you actually know that there is like some bottleneck or issue with it. So don't do that. But then, of course, there might be 3% of the time when there is actual some sort of critical points where you should go ahead and optimize, and then you should do it. Yes, of course. But 97%, don't do it. And maybe it is the root of very, very much evil in the programming business. So premature optimizations, try to avoid that. Separations of concerns. That is actually a bit that gives us a value of code quality. So basically it says we should divide our code in modules, and we should separate them so they should stick together. So separation of concerns, the things concerning this should go there, the things concerning that should go there. So it's a separation, organization of the software. And then we say that high cohesion, which is a software metric, it's could be used as such when we sort of providing some figures on how good our code is. So cohesion is one metric for that. So high cohesion, that is what we're striving for. That means that a module and the parts of the module belongs very much together. So when we have a module, all parts in it should really, really belong to that module. Then we have a module with high cohesion, and that is very good when we're talking software quality. The law of Demeter, LOD, or principle of least knowledge, that is about something that is called loose coupling. And loose coupling is also a quality metrics of software modules, and it means basically that the modules shouldn't have too many friends. Our modules shouldn't talk to many friends of friends and friends. Should merely talk to the closest relatives, the closest friends, or the closest units to it. And it should, when it has sort of, okay, I need to talk to 10 other modules or 10 other units, well, that's not loose coupling. That is rather tight coupling. All the modules talk to each other. They are very sort of tight coupled. And this is sort of a sign of software that might be really hard to maintain, because if I change one module that has this very high coupling to a lot of other modules, then there may sort of be consequences. I also need to change that, and that has also tight coupling to other modules. I need to change that. So loose coupling will make it easier to maintain the software because it hasn't too many dependency on other software modules. So high cohesion, a module is keeping together its stuff, only relates. High cohesion and loose coupling, let's have the modules stand alone as they can, and don't let them talk to too much other modules. High cohesion, loose coupling, That is measurements for good software quality. And technical debt is what happens when we leave bad code behind. And maybe you have sort of went into an old project of your own, or in the company, or from your friends, that is sort of you're looking at, okay, what's happening here? Oh, that's not dry. We need to rearrange that code. We can work it into module. That module has very, what is it? High coupling, very hard to work with, very hard to change. So all these bad codings that exist in such an application, that is a technical debt, because we can relate these bad codings to costs of fixing them. So that is the debt. So a bad software could have a very high technical debt because it will cost a lot of money and times to go in there and fix it. So we try to avoid technical debt. I wouldn't say that the technical debt is bad, but we should be aware of when we're having a software that has this technical debt, because it will be cost some to go into it and fix it. And relate that to a software with low or non-technical debt. Well, that is fair, not too sort of costly to go in and fix. So we should be aware of it. And then, sure, if I'm sometimes leaving technical debt, yeah, let me be aware of it. Okay, just see. There we go. I missed this one. Because this one, broken windows, that is also related to the technical debt. So it's a crime theory stating that visible signs of the crime sort of enhances or creates more crime in a sort of area of buildings or where people live. So it is actually saying, and we can bring this with us to the software world, that when someone breaks a window on a large building, if you do not fix that immediately, then that is a sign saying, okay, it's okay to break windows here. And maybe someone breaks the other window. So you got 2 broken windows, and then you got 4 and 8, and you're leaving a lot of what we can call it technical debt down there. So you should be aware of when you are in your code and you're sort of crashing a window, that is sort of you're leaving some bad code there, your code fix. No, I'm not gonna mend that now. Just gonna leave it. I know it's a broken window, but that is also a technical debt that I'm leaving behind. So you should be aware of it and be a bit sort of cautious, because when you start leaving those broken windows, they will sort of one more, and then there are way too many to actually sort of, this is a lot of work to fix this. So that is a broken window. If you manage to keep on top and always fix the broken windows, yes, then you have most likely low technical debt in your software application. Okay, so let's see. Let's have some. I have some more philosophies before we end here, and these are purely on planning. So the other ones there were, well, it was a lot of how we relate to our coding and taking sort of different decisions on what type of code I'm going to do now. But these are sort of helping us with the planning. So we can take Hofstadter's law first. And that's saying, well, it's just stating that it's really, really hard to approximate things or estimate things and say, how long will it take for you to develop this software product? And Hofstadter's law says, well, it always takes longer than you expect, even when you take into account the Hofstadter's law. So it's basically saying, well, it will take longer than you expect, and there is no way around it. So this is just stating that it's really hard to sort of estimate the time and effort needed to do programs in general. The planning fallacy, that's more or less equal, but it's saying that we are optimistic. Many of us, majority of us, I think, would be optimistic as a default. So when someone asks us to complete the task and we want to sort of say how long time it will take, many of us will sort of say, yeah, we know how much time it could take if we did it the way we think we should do it. So we're bringing our optimism into this. So we're taking best choice, best effort. But in general, there are perhaps not always this best case scenario. So most often perhaps we are underestimating the time that is actually needed. So it could be good if you are a manager, project leader, or you just want to be sure that your team is holding the deadline, then you should know that optimism bias could be could be at your table when you're sort of talking about how long stuff will take. SMOP is a small matter of programming, and that's a very humoristic way of saying, yeah, that's not too hard, I can fix that. That's just a small matter of programming, not a big issue. And then I say it could be good to know, learn when a SMOP is a real SMOP. And here SMOP is not a small sort of matter of programming, because it has consequences and we need to do that and that and that. And sometimes you are aware of that. Sometimes you know that someone else tells you that's a SMOP, and you know, no, it's not. It's a lot of things I need to do to actually make that happen. That is not a 5-minute fix. It's a 5-hour at least work to make that whole change, update the code base, write the units test, freeze it, release it. It is not what I would call a, well, small matter of programming. Yeah, that's actually SMOP. You thought it was a small matter, but it was actually a large one. I could relate to, I had a SMOP just a week ago. Someone asked me if I could come home to them and install their new intelligent vacuum cleaner, you know, those who goes around self in the room. So yeah, I can do that, I said. So I thought I'd just go over and press the button and sort of install the app, and then I was done. But I got there and it started somewhere like, well, this house does not have a good Wi-Fi network, so this won't even work. So then I need to fix the Wi-Fi first, and that took a lot of hours because this was a Wi-Fi I didn't sort of was acquainted with. So that I thought this time I thought, yeah, no, it shouldn't be too hard to just press the play button on your vacuum cleaner. But yay, it was a lot of things I had to do, and it took a lot of hours to do it. So let's try to recognize these SMOPs to save some time. The 90-90 rule is some humorous aphorisms stating that the first 90% of the code. So the first 90% of the code takes 90% of the time. Sounds fair. And then the final 10% of the code, well, it's going to take another 90% of the time. So it's basically saying to us, be aware that only if the first part is sort of moving on and taking its time and then you think you're done, remember that these final part may be the hard parts, and they may also take a substantial amount of time to actually do these small final codes lines to make it all work. So 90-90 rule, yeah, just because it was easy at first doesn't mean it will be easy to end this up. Um, the law of triviality. Can we use that as a software engineers? Well, yeah, we can use it because it's a general management rule. And when we produce software, we are often doing it in a team and a group, and we sort of need to relate to how the group is working. So yeah, I think we can relate to this in our sort of when working in teams developing software. Anyway, the law of triviality is that when a team organization, they sort of they give disproportionate weight. We're putting too much effort into discussing very trivial matters, and that is reasonable basically because it's very easy for all the team members to have an opinion about these easy issues. But then, on the other hand, the hard issues that maybe are so much more important to discuss, they might be so hard to understand and grasp. So the people do not tend to discuss it because it's too hard. So this is also known as the bicycle shed, and the example goes like a group of people sitting there and they're discussing very much how to repaint the bicycle shed, and everybody is so involved in the discussion and saying that and that. And then they go to another point saying, okay, we're going to do a major investment here on a nuclear plant. It's like 3 billion money. All agree? Yes, all agree. So no discussion when there is such a large, important decision. But many sort of discussions when it's just what color of the bicycle shed should we have. So try to detect when your team organization is doing this. You are sort of you're bicycle shedding it. You're giving too much time to these trivial issues. You should be able to just remove them from the discussion and move ahead to the more important stuff and talk about that. Okay. There we go. So let's sum this up and see what we have here. Well, all of these philosophies, or principles if you prefer, they sort of put our thoughts into words. They give us some terminology to discuss when it's going to design and code structure. And we can also make active choices because we are thinking first and we are maybe using different principles that sort of completely takes us into different roads of the code. But they are both fair, all fair. But since I'm sort of relating to them and I know what type of principle they are, what consequences they have, and I'm making these active choices and I'm thinking before. So that's how these software philosophies or principles actually help me to reason about the code. And they are sort of also showing that it's fine to do all these different choices. It all depends on the situation and what I'm sort of prioritizing currently. It's even okay to make what other would say bad choices. Perhaps like I have a copy and paste. Could one do that? Yeah, I would say you can. If you are aware that you are doing copy and paste and that is actually the best solution at this given time and circumstance. Okay. So gives you help to reason. Maybe I choose to do a quick fix. I was aware of it, but obviously it did not hold. So I'm gonna do over. I'm gonna do right and get rid of the technical debt. No broken windows in my code here. So putting all this into sort of context where we can discuss with our teammates on how should we do this with our code then. So use these principles when we're solving issues. What is the right path to go here? given the context we are in, given the project, given the team, the delivery time, what sort of principle is that we should go here now. So yeah, and there were many of them that that we talked about today. So we got Python, Dry, Kiss, Pogi, Agony, Parade, to copy paste, don't fix it, poke fake, overdo it, satisfying versus better, and so on. So try, you know what? Try to remember a few of them, and it's fine if you take the funny ones. Sometimes it's easier to remember the funny ones, and somewhere on the road we could sort of start to grab one or two or three of these philosophies, principles that will help us relate and discuss to code. If you are on your own, you can do this, and you should choose to use the duck. I guess you have heard about rubber duck debugging. That is when you're sort of debugging your code with the aid of your friend, the rubber duck. And the idea there is to ask questions or sort of put statements to the duck and wait for the duck to answer. It won't answer, but still, the whole idea behind this is when you are formulating a question or a statement and you're actually saying it out loud, that will sort of help your brain kick on and try to do the problem solving you're actually trying to do. So yeah, many people think, many programmers think that it is actually useful to sort of have this rubber duck debugging, ask the questions to myself or to the duck, and that would actually help. So you can talk to the duck here about these software principles and discuss, relate. What should I do here, my duck? Should I go ahead with this copy and paste programming? I don't have too much time and I don't care about the technical depth. It's not actually a broken window here. I'm fine. It's okay. So discuss with your duck and your peers, and that is a way to go ahead and start using some of these sort of principles. So there we go. That was all I had for today, and it was discussion on guidelines, tricks, giving you a terminology, and some of it is rather fun to use, to discuss and relate to all the choices you actually do on an everyday basis when you sort of decide if you're going to write nice code or quick code or dirty code or whatever it is. So try to use a few of them and take it from there. And I'm going to say bye-bye for now, and I'm going to see you on another session. Okay? Bye-bye.